we discussed about adding water to double bonds. In the end, we actually talked about the three different conditions. And then I want to talk about the first one, the less efficient one too, which is basically dumping double bond into the acidic water. Proton will be added to pi bonds, which make a carbocation. But something that I've been telling you, whenever you see the carbocation, first thing that should pop in your mind is it may rearrange. Right? That is something we really need to think about as soon as we see carbocation. This carbocation is a secondary carbocation. There's a tertiary center next to it. So I'm expecting it to rearrange very fast. Once it rearrange, I mean, it can capture the water, but the thing is that these are going to be minor products. It can rearrange, make the hydrogen shift. It takes up the water substitute carbocation. That will capture the water. That will produce a different alcohol. And I'm expecting that's a major part because of the arrangement makes the more stable carbocation. So this type of question, you intentionally put it there because we kind of expecting you're going to do this, but that's another part. That's not the correct answer, right? So you really have to be aware of that. If you make a carbocation, no matter what way you're making it, the rearrangement is something you need to think about. But if you can do it without the worry about the rearrangement, and that's the oxymercuration, demercuration. Mercury acetate will make a breached ion, right? Mercury breached ion. The mercury will pull electron density for the polar it bounds to, but the more substitute side will lose more, right? And that's where the water molecule makes an attack. So water goes, OH goes to less more substitute side. The mercury, because it's an alkyl mercury, it's different from the vinyl mercury. It doesn't go away easily. You have to remove it by adding sodium borohydride, second step. So this is a Markov nickel products. OH on the more substituted side, hydrogen on the less substituted side. And then it's an anti-addition. It doesn't show it, but you're going to aware it's going to be anti-additions. There are another way of adding water to double bonds, which is a hydroboration, which is a BH3. BH3 is going to be added, hydrogen and the boron will be added together at the same time. Boron is going to be on the less substituted side because it's murkier. Hydrogen is going to be on the more substituted side because it's smaller. The syn addition because they're adding at the same time. The boron will be replaced by the OH in the second step, oxidative walk-up. So you get the anti-Markov products. So this is basically what we discussed in the previous chapters. Now, I'm going to show you what it's going to look like adding water to the triple bond. We talked about two different reagents. One, the mercury sulfate, the sulfuric acid. This is kind of analogous to this condition, oxymercuration, demercuration. Diethylborane and oxidative walk-up is kind of analogous to the hydroboration reaction, right? It's boron, so it's kind of has to go same way. The mercury sulfate, add the water, and it makes a Markov nickel products. This is a more substituted side, there's a less substituted side. So you can put the OH on the more substituted side, hydrogen on the less substituted side. You most likely put it as a product, but if you do, you're going to take forms away because that's what you're going to see in the end. It will change to the ketone form. So that's the part that you really need to remember. Binary alcohol is not stable. It changed to ketone forms. Because OH on the secondary carbon, when it becomes a carbonyl, it becomes a ketone. Hydrobor, I would still say it's Markov nickel products because OH is sitting on the more substituted side. This silane will add OH on the less substituted side, just like this one does. This is anti-Markov nickel products. But again, this is a binary alcohol. This is enol. It will tautomerize. The OH becomes a carbonyl. But since there's only hydrogen there, it becomes an aldehyde. So this is a ketone, there's an aldehyde, right? That's only because of their positions. And their substitutes are different. So this is an anti-Markov addition, and you can see that the products of adding water to bond is not alcohol, it's actually the carbonyl containing species, and it could be either ketone or aldehyde, depending on how you do it. So I really want you to see the differences of these. because a lot of people make a mistake.